today's lesson, we're going to learn how to calculate the heat of a reaction from the bond energies of the molecules present in the reaction. So the reaction we're going to look at today is the combustion of methane, which is CH4, methane, reacting with oxygen to produce carbon dioxide and water. So when we draw the Lewis structures for each of these compounds, it lets us know what type of bonds need to be broken for the reaction to happen and what new bonds are going to be formed during the process. Now, this is an exothermic reaction, and as we learned in the thermochemistry unit, when you have an exothermic reaction, your reactants have a higher internal energy than the products, but you still have to overcome some hump or activation energy for the reaction. That hump is a result of the fact that breaking bonds is an endothermic process, and it requires an input of energy. Once those bonds are broken and the new bonds can form, energy is released during the second half as it is an exothermic process. And we just, in order to determine whether a reaction is exothermic or endothermic, what we have to look at and compare is the amount of energy required to break the bonds and the amount of energy released when the bonds are formed. So if more energy is released when the new bonds are formed than was required for the new bonds to break, or the original bonds to break, you're going to have an exothermic reaction, and vice versa for an endothermic reaction. So looking at this, the bonds that need to break are, you have 4 carbon to hydrogen bonds. Each one of those bonds requires 413 kilojoules to break a mole. That's the energy input. So to break all of those, it requires 1,662 kilojoules. In addition, we need to break 2 oxygen molecules apart. So I'm breaking 2 O to O double bonds. And each one of those bonds requires an input of 498 kilojoules to break, giving us a total energy input to break apart the reactant molecules of 2,658 kilojoules per mole. Then, for the bonds that form, we have 4 oxygen to hydrogen single bonds, and then we have 2 carbon to oxygen double bonds that need to form. In each of those bond energies, the OH bonds are 464, 4 of them, that's 1856 for a total energy for that. And then in the formation of the carbon-oxygen double bonds, 805 kilojoules per bond. 2 of those is 1610. So calculating the overall energy of the reaction, what you have to do is take the energy required to break the bonds and subtract from that the energy associated with the new bonds forming. So since the new bonds forming is going to release energy, we just put this negative sign here to indicate that energy is going to be lost during that process. So we have our positive value for bonds breaking, negative value for bonds forming. It's going to be like that every time. Since we have more energy released when the new bonds are forming than energy required to break the bonds, you're going to end up with a negative value for the heat of the reaction, and this process releases 808 kilojoules per mole, making it highly exothermic, and that's why we use it to heat things up in the lab.